Hello everyone! In this video, we are going to learn the length of an arc and the area of a sector. In this circle of radius r, the length of an arc, referring this piece in here, that subtends an angle theta is denoted by the lowercase letter s. Looking at this picture, we understand that the arc length represents a portion of the circumference. So in other words, S equals to a portion of the circumference with the circumference formula equals to 2 pi r. So then this piece in here covers theta out of 2 pi radian. So which is theta over 2 pi. As we simplify the formula, we will have S equals to theta times r, where theta is in radian. Now, let's look at example number 1. Find the length of the arc of a circle of a diameter 12 meters subtended by the central angle 60 degrees. So that we are given that diameter equals to 12 meters and the central angle of 60 degrees. To find the arc length, we use the formula S equals to r theta, so that we need to know what is the radius. If the diameter is given to us 12 meters, then radius it is half of the diameter, which is 6 meters. In order to use this formula, theta must be in radians. However, in this example, the angle is given in degrees, so that we need to convert from 60 degrees to radians, which we will multiply by pi radian over 180 degrees. As we simplify, we find that theta equals to pi over 3 radians. Now we will substitute. S equals to 6 times pi over 3 radians, and we find that S equals to 2 pi meters. Example number 2. Find the radius of a circle if an arc of length 15 meters on the circle subtends a central angle of 5 pi over 6. Please feel free to pause the video so that you can give it a try. Find the radius of the circle, so the radius is an unknown. If an arc length 15 meters, S equals to 15, on a circle that subtends a central angle of 5 pi over 6, so theta is given 5 pi over 6. So then we will again use the arc length formula. S equals to r theta. S is given to be 15. The r is an unknown. Theta is given to be 5 pi over 6. And that's it. This is our setup of the problem. Now, we are going to multiply both sides by 6 over 5 pi to solve for r. And then now, in this case, we will reduce with 5 and 15. We have the final answer, 18 over pi meters, equals to our radius. Area of a sector. We are interested looking at the area of this piece sector. In a circle of radius r, subtends a central angle theta. We can see that the sector covers portion of the circle, so that the area we can find that by a portion of the area of the circle. Area of the circle we can find it by pi r squared. And then now this piece covers theta out of 2 pi radian of the circle. Now we will simplify the formula, and now we will have A equals to half pi r squared, where r is in radians. Example number 1. Find the area of a sector with central angle 2 pi over 3 radians in a circle of radius 16 centimeters. Please feel free to pause the video so that you can give it a try. In this case, we would like to find the area of the sector, so A is an unknown. With the central angle 2 pi over 3 radian, so given that theta equals to 2 pi over 3 radian. In a circle of radius 16 centimeters, r equals to 16 centimeters. So that in this case, it suggests us to use the area formula, which was A equals to half theta r squared. So A equals to half times the theta 2 pi over 3 times the r, which is 16 squared. Now we will have A equals to the 2 we can reduce. We have pi over 3 times 16 squared, which is 256. So our final answer, A equals to 256 pi over 3 centimeters squared. Thank you very much for watching my video.